For lesson 12, we're going to start with our next form of solving, which is called the quadratic formula. So far we have learned our inverse operations, factoring, completing the square, and our fourth algebraic one is going to be the quadratic formula. So if we look at the opening exercise, we're going to solve the quadratic equation 7x squared minus 12x plus 4 equals 0 by completing the square. So if we remember back, the first thing we do is when there's a number in front of x squared, we take it out as a GCF from the first two. But then look what happens here. We get 12 over 7x, and then at the same time we can do our plus a line, and then we had plus 4 minus a line equals 0. So I'm going to fix this so it looks a little bit more like a 7. So what was our rule? Our rule said we took the middle term, which was 12 over 7, or negative 12 over 7, we divided it by 2. Well, that gives us negative 12 over 14. We're going to square that. And as we go through this process, what you'll see is it's very challenging. And factoring is not an option here. Completing the square looks absolutely terrible. So what we want to do is we want to come up with a different way that we can solve these problems that's going to make problems that look like this a little bit easier. Okay? And we're going to skip around in this lesson a little bit. So what I want you to do is I want you to go here to the part of your packet that says we just derived the quadratic formula, which states if ax squared plus bx plus c equals 0, then the solutions are. And now this is going to be our quadratic formula. X equals negative b plus or minus big square root b squared minus 4ac all over 2a. Now, as you look at that formula, it looks pretty terrible, but it's going to be really important to understand that you don't have to memorize it. It is on the reference table here. You can see x equals negative b plus or minus big square root b squared minus 4ac all over 2a. So on the Regents, you'll have it. Any quiz or tests, you're going to have that in front of you. So you don't have to worry about memorizing it. You just have to worry about how to use it. And using it also looks much more challenging than it actually is. So if we look at the number 4 here, it says solve each of the following quadratic equations by using the quadratic formula. So x squared minus 3x minus 8. The first thing we always want to do is we always want to write down a equals, b equals, and c equals. A is always the number in front of x squared. Well, what's in front of x squared? Nothing, which means there's really an imaginary 1. B is always the number in front of x, so negative 3x means b is negative 3. And then c is our constant, so negative 8. Okay. Now, I'm going to write down our equation again. X equals negative b plus or minus big square root b squared minus 4ac all over 2a. Okay. So as we go to fill this in now, x equals negative b, and actually maybe I'll put this on the last piece here, just as a little hint. Negative b is really just the opposite sign of b. Okay, so it's the opposite sign of b, which means since b had a value of negative 3 here, the opposite sign of that is going to be a positive 3. It's always a plus minus, big square root. Now it's regular b squared, so negative 3 squared, we always put it in parentheses, minus, it's always a 4, a is 1, c is negative 8, and then the whole thing is going to be over 2 times a, which is 2 times 1. All right, so now we're going to put this in our calculator in pieces, and we always go in the same order. So now as we go to put it into our calculator, we're going to take everything that's underneath the square root, except for the square root, and put it in our calculator. So we're going to put the negative 3 squared minus 4 times 1 times negative 8. That's all going to go in our calculator at the same time. And you want to be very careful on your signs here. Okay, make sure you have your negatives in the right place. Make sure it's always a minus sign in front of the 4. And then we're going to hit enter. So we get 41. Okay, so if we go back to our notes, we have x equals 3 plus or minus. That big square root just turns into the square root of 41. And then the bottom we could just do 2 times 1, which is 2. So the next thing we want to do is we want to look at our square root and go, okay, is it a perfect square? If the answer is yes, then what we'll do is we will take the square root of it and we'll finish our solving. If the answer is no, then the next thing we're going to do is we're going to look to split it. So now you got to think, does 41 actually split? And the answer to that question is no. So then what happens? Well, if we want to use, especially if we want our answers in simplest radical form, there's our answer. Okay, and we don't have to go any further with that piece if they say simplest radical form. Sometimes they'll say round, and we'll work on that as we get a little bit more familiar with the quadratic formula. But if we can't go any further with our answer, then we just have to stop right there. Okay. As we look at the next one, y squared minus 2y equals 12. First things first, just like all of our solvings that have a y squared or an x squared or something like that, it's always got to be set equal to 0. So we got to subtract the 12 on both sides. Y squared minus 2y minus 12 equals 0. So then we're going to label our A, our B, and our C. So A is still 1, B is negative 2, C is negative 12. Now, there's a chance that this could have been factorable. You never know. But we won't find that out till the very end if we're going to use the quadratic formula. So the formula is over here on the left, so I'm not going to write it again. So the first part says negative b, which remember means the opposite sign of b. So if b was negative 2, negative b is positive 2. Plus or minus, big square root, b squared, so negative 2 squared, minus 4 times 1 times negative 12. And then all over 2 times a, which is 2 times 1. Okay, so now we'll go back to our calculator and we'll put just what's underneath the square root in there. So in parentheses, negative 2 squared minus 4 times 1 times negative 12. When I do that, I get a 52. So x equals 2 plus or minus square root of 52 over, and we might as well do 2 times 1, which is 2. Do not cross these parts out yet. Okay, we have to work with our radical first. So again, our process. Is 52 a perfect square? It is not. So the next thing we do is we go over here on the side and we look to split 52. Does 52 split? And the answer is yes. Square root 4, square root 13, comes back together to give us 2 square root 13. So now what we're going to do is we are going to substitute that in for the square root of 52. So it becomes 2 plus or minus 2 square root 13 over 2. Now you look at all the numbers that are not underneath the radical, and you look to see if you can divide them by everything. Well, obviously, if they're all 2's, we can divide them all by 2, and that gives us 1 plus or minus. Now you could put 1 square root 13, or you just have to put square root of 13, and then you don't have to put over 1, so there is our answer. So you can start to see that some of these develop in a little bit of a different way towards the finish, depending on what the problem is. So if we look here at the next two, so again, it's got to be set equal to 0, and as best as possible, we always want to keep our x squared term positive. So I don't want to move the 2x squared over. I prefer to bring the other pieces over to the other side. So 2x squared plus 8x minus 7 equals 0. So a is 2, b is 8, c is negative 7. So I'll write my formula up here again so we can see it. X equals negative b plus or minus big square root b squared minus 4ac all over 2a. All right. So negative b, well in this case b is positive 8, so on the outside here goes a negative 8 then, opposite sign. Plus or minus big square root 8 squared minus 4 times 2 times negative 7. I forgot my x equals over 2 times 2 in this case because there was an actual number in there for a. So we'll go back to our calculator and put everything in. So 8 squared minus 4 times 2 times negative 7. When I do that, I get square root of, or I get 120. So x equals -8 plus or minus square root 120 over, and 2 times 2 is 4. Again, do not cross the 8 and the 4 out yet. We have to work with the 120. 120 is not perfect. Let's see if it splits. Remember, if you can't figure out what the numbers that multiply to give you something is, go to your calculator, go y equals, do 120 divided by x, and you go to your table. And as I look through all of our combinations here, the only one with a perfect square that I see is this 4 and 30 piece. So square root 4, square root 30 gives us 2 square root 30. So then x equals -8 plus or minus 2 square root 30 over 4. So again, we look at the numbers on the outside, -8, 2, and 4. Is there anything we can divide all of them by? And the answer is yes, we can divide them all by 2. So that gives us -4, 1, and 2. So that leaves us with x equals -4 plus or minus, again, you could put 1 square root 30 or just square root 30. And now we have a number on the bottom, so we have to go over 2, and there are our solutions. And for our last one, 3t squared minus 4t minus 4 equals 0. A is 3, b is -4, c is also -4. All right, so we've got our formula here on the top. So x equals -b becomes a +4 plus or minus b squared, so -4 squared, minus 4 times 3 times -4 over 2a, which is 2 times 3. So we'll go to our calculator here, go back to our main screen. -4 squared minus 4 times 3 times -4, not -14. And we end up with 64. So x equals 4 plus or minus square root 64 over, and 2 times 3 is 6. So the nice part about this one is 64 is a perfect square. The square root of 64 is 8. Now, by the time we've gotten to this point, we've been kind of just circling our answers because they've all had radicals left in them. But since this one turned out to be nice, and what I mean by nice is there are no more square roots in them, we now are going to finish this off and get actual answers. Okay? 4 plus or minus 8 over 6, which means we need to do 4 plus 8 divided by 6, and 4 minus 8 divided by 6. Well, 4 plus 8 is 12. 12 divided by 6 is 2. So there's one answer. 4 minus 8 is -4. -4 divided by 6. Well, that gives us a decimal, and we're just going to simplify that to -2 over 3. And there are our two answers. Okay. By the way, when you end up with answers that are real numbers, not real numbers, that are rational numbers like this, that means your initial piece was factorable. Okay, and you could have put it in the boxes and gone from there. But I think the quadratic formula is kind of nice because it gives you a steady process to use every time that works for all types of our answers.